right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 35 is on the screen. Let's get started, please. Numbers 2, 3, and 4 should be a piece of cake. I brought back number 1. Hopefully you remember from week 2 of the school year and week 3. We were doing those, remember? Oh, yeah. So I'm bringing these back. We're going old school. So I'll give you some time. Copy and go. All right. So let me go over the warm-up really quick. Number 1. Let's see. Hopefully we remembered. Yes? Yes, Mr. Q? Let's see. Mr. Q, yes. How do we solve these? Are these a proportion? No. Because now we have 2 fractions on one side and 1 fraction on the other. That's why we cannot cross-multiply. So what can we do? Oh, we multiply times the common denominator. Oh, I remember these. Common denominator for 2, 3, and 12 is 12. We multiply times all 3 numerators. So that gives us 12 over 2x, which is that, plus 24 over 3, which is this, equals to 60 over 12. Next, can I simplify this? Yes. 6x plus 8 equals 12. Oh, my bad, equals 5. And the rest is history. Minus 8 minus 8. 6x equals negative 3. And last but not least, divide by 6. X equals negative 3/6 or negative 1/2. All right, number 2. Factors for number 2. What you get for your factors, please? Fredo. X plus 2 and x plus 1. That is correct. So, before I ask Valente for the factors of number 3, tell your neighbor what you got for number 3. Share with your neighbor what you got for number 3. All right. Factors for number 3. Who did we say? Oh, Valente, what'd you get? Well, let me walk you through it. Is it in standard form? Yes. Is there a GCF? No. What are the red flags? It's a binomial, a minus, and a square. So what do I do? Swish. Let's go. Square root, yeah? Square root and square root. Therefore, my factors are 2x plus 7, 2x minus 7. Hands if you got that? All right, good. Way off. Number 4, minus 15x minus 15x. We got 5y equals negative 15x plus 10. And last but not least, we divide by 5. Divide by 5. We got y equals negative 3x plus 2. And if you got that by yourself, okay, good. Let's get our table for the domain. The domain we have negative 2, 0, and 1. Now before I continue, tell your neighbor the name of all the y's. What is the name of all the y's? Since I've been repeating this for a full week now. Yeah, very good. It's the range. Write it down if you forgot. Oh my goodness. Bah. All the x's are what? The domain. All the y's are my range. All right, here we go. I'm going to substitute the negative 2 first into here to the x. So negative 2 times negative 3 is 6 plus 2, that's 8. Next value. 0. 0 times negative 3 is 0 plus 2, that's 2. Last but not least, 1 times negative 3 is negative 3 plus 2, that's negative 1. All right, let's cross that. Nice and straight like mine. Let's see. Look at that. That's gold. This is my y-axis, my x-axis. Let's graph this. My first point is at negative 2a. Negative 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Bless you. So that point is about right there. It's a little bit off, right? Let me move it to the right. There you go. A little bit better, yeah? All right, next point. 0, 2. 0, 1, 2. And the last one, 1, negative 1. 1, negative 1. Graph. And by the way, every time we graph, we always go from left to right. Start with the point farthest to the left, move your way to the right. If we do that, and if we're reading this graph, tell your neighbor in which direction is that graph going. Which direction is it going? From left to right. Very good. It's going downward. From left to right, it's going down. That's why this is a negative slope. All right, copy the agenda for today. Here we go. Got warm-up number 35, product and quotient of rational expressions. And your home place pages 446 and 447 only. Today is packed with a lot of stuff, but it's fairly neat. It's a neat lesson. I think it's one of the easiest ones of rationals. That's just me. That's my opinion. However, we do need to finish with both product and quotient. What does that mean? Multiplication and division of rationals. Multiplication and division of rationals. Okay? So, y'all ready? Those that already copied the agenda, make sure you go to the to Canvas, turn in your home plate from last night. And some of you haven't turned in your signed screenshot progress report. Turn that in as well. And then get a Cornell note ready, please. It's going to go pretty quick. All right, here we go. Our objective for today, I can multiply and divide rational expressions. I can multiply and divide rational expressions. Do we need a Freyer model? No. Tell your neighbor in your own words the definition for rational expressions. Definition of rational expressions in your own words. And then we'll ask JP for the definition. All right, JP, definition for rational expression in your own words. Yeah, fractions whose numerator and denominators are polynomials. Hands, do you agree with that? Yeah, we got that. And we have our Freyer model that was filled already since we got started with this whole thing. Then I gave you guys a definition for rationals. Is that correct? Now, mind you this, just so that we can remember, because I'm going to come back to this, but here it goes. The quotients or rationals are made up of all fractions, where m and n are integers. Everybody know or can think of integers? Yeah, 1, 2, 3, 4, 5, and all the negatives, and including 0. However, the denominator cannot be what? 0. Okay. So, write your utensils down. Put everything away. Leave everything aside. Eyes on the screen. So I'm going to go back to elementary. And I think they introduced this to you. I think it was in second, third grade. Yeah? So here's a throwback. Multiplication. Multiplication of fractions goes as follows. Just pay attention. You already know this. 2/3 times 3/4. So, how do we do that? Well, numerators times numerators, that's 2 times 3 is 6. Denominators times denominators, that is 12. Next, can we simplify this to lowest terms? Yes, you know the old school of doing it, but how did I ask you to do it? GCF between these two numbers is what? 6. So I would write 6 times 1 and 6 times 2. So far so good? And then from there, the giant 1 is what? 6 over 6, so this becomes 1/2. Okay, go to division. 2/3 divided by 3/4. Let's see. Tell your neighbor if they remember what to do with division before I ask Frida. Let's see, Frida, what's your neighbor say? No, let's ask Jose. Jose, what's your neighbor say? All right, I think some of us forgot, but here it goes. Your teacher said keep the first fraction the same, change division to multiplication, and then you're going to multiply times what? Reciprocal, which is 4 over 3. And we know how to multiply, yes? All right, however, let me focus here really quick. Why do we do that? Julian? So multiplying by the reciprocal is backwards, okay? That's one way of looking at it. However, the reason being is because of the definition of fractions. Here's the definition of fractions again. Pay attention. M divided by N. What did we say M and N are? M and N are integers. Yeah. Integers, yes? And what are integers? 1, 2, 3, 4, 5, and negatives and 0. However, the denominator cannot be 0. Is that correct? So let's keep that in mind. Let me show you why, because of this, we do this. Here it goes. I'm going to start off with what? 2/3. And then what does it say? Divide, yes? By 3/4. Doesn't that look weird? Why? Because the definition says that the denominator and the numerator need to be what? Integers. So can we have a fraction? No. So how can I get rid of that fraction? Well, what can I do to that fraction to make it the simplest number of 1? Multiply times what? The reciprocal. And whatever we do to the denominator, we do to the numerator. Therefore, what do we have here? 2/3 times 4/3. And do we need to write the 1 underneath? No, because it's the same thing. That is why we do the reciprocal, because of the definition. We cannot have fractions or decimals in the denominator. Anyways, you don't have to copy this. You don't have to memorize this. However, are we good with the mechanics of multiplication and division? Yes? All right, because that's just with numbers. What are we doing today? Polynomials, let's go. Let's go. Copy these steps down, please. Steps 1, 2, and 3 for multiplication. I'm going to use those same colors, so if you have your colored pens, get those ready. Step 1 says factor completely. Step 2, multiply the numerator and denominators. Step 3, simplify by dividing common factors or giant ones. Copy that. Give you some time. Funner by the minute. Here we go. So we're going to follow these 3 steps. If you have those colors ready, have them ready, or at least have 3 different colors. Copy example number 1. It says compute the product or quotient, then simplify to lowest terms. Also identify the excluded values. 3x squared over x squared minus 2x minus 8 times 2x squared minus 6x minus 20 over x squared minus 3x minus 10. Doesn't that just look like the fractions that we just showed right now? All right. So, since we already know all the processes, we're going to do this one together. We're going to go slow, but together. Okay? I'm going to start with the color green. Here we go. I'm going to start with step 1 that says factor completely. What do I factor completely? Everything. Start with the first fraction. Look at the numerator. We have 3x squared. So, question. What do we check? What are the first 2 things we check before we factor completely? Tell your neighbor once more. Standard form and GCF. Okay, let's look at the numerator. Is this in standard form? Yes, it's pure monomial. Is there a GCF? No. So can I factor that completely? Yeah, that's 3 times x times x. Go to the denominator. Is this in standard form? Yes. Is there a GCF? No. So tell your neighbor how to factor this one. We got -8 on top, -2 on the bottom. What factors of -8, when you multiply them, give us -8? When you add them, give us -2. Tell your neighbor, please. What 2 factors of -8 add up to -2? Lorena, go. -4 and +2, so my factors are x minus 4, x plus 2. We're done with the first fraction, times. Go to the second fraction, numerator. Is it in standard form? Yes. Is there a GCF? Yes, what is it? 2, and we're left with x squared minus 3x minus 10. Can we continue factoring the trinomial? Yeah. -10 and -3. Tell your neighbor the factors of -10 that when you add them give us -3. All right? Dulce, -10 factors that when you add them give us -3 are -5 and 2. So my factors for the second numerator is x minus 5, x plus 2. However, don't forget the BFF, which is what? 2. Okay? X plus 4 for this one? Like this? Oh, -10. All right, let's see. Yes, okay. And then, but since this one has a leading coefficient, yeah? The circuit? Okay. All right. Look at the denominator. Who notices that this one is the same as this? Yeah, so we write what? X minus 5, x plus 2. All right. We're done with step 1. Let's go to step 2. Multiply numerators times numerators, denominators times denominators. Now look up. I'm not going to actually multiply and simplify. I'm just going to multiply, or in other words, I'm going to write it as a factored form altogether. I'm going to start with numbers first, then variables, and then binomials. Here we go. 2 times what? 3, so I'm going to write 2 times 3. What else? X times x. X times x. Now I go with my binomials. X minus 5 and x plus 2. X minus 5, x plus 2. We're done with the numerator. Let's go to the denominator. Where do I start? Right here. X minus 4. Next, x plus 2. Next, x minus 5. And next, x plus 2. We're done with step 2. Let's go to the last step. Identify giant ones so we can simplify. Tell your neighbor the giant ones, please. What are the giant ones? All right, Fabian, go. X minus 5 and x plus 2, yes, those are my giant ones. So we're left in the numerator. 2 times 3 is 6, x times x is x squared. And the denominator, I'm going to leave it in factored form. We got x minus 4 and x plus 2. And we're done. You're like, that's it? That's it? I told you guys that I thought it was simpler than addition and subtraction, right? From 1 to 5, how simple are you up to right there? 5 fours, yeah. However, they want us to find the excluded values. Now look what I'm gonna write. Check this out. Excluded values, pay attention to this. X minus 4 equal to 0. X plus 2 equal to 0. X minus 5 equal to 0. Talk to your neighbor, see where I got that from? Where did I get that from? Let's see. Joel, where do I get that from? What's that? Oh, okay. All right, so let's see. Over here at the end, we have x minus 4, x plus 2. Okay, but where did I get this from? Frida. Another factor, okay, which means, check this out. From now on, for multiplication and division, we need to use the original denominators. Let me show you. Original. What are the factors of this one? What are the factors of this one? And that's how I get these. Make a note for yourself so you won't forget. Asterisk, art, Then we solve. Plus 4, x equals 4, minus 2, x equals negative 2, and plus 5, x equals 5. These are my excluded values. So let's see. Do I have all of them? X minus 4, yes. X plus 2, yes. X minus 5, yes. X plus 2, I already have it. I don't rewrite it again. There it is. All right, I think we got it, yes. A little bit like our noodle starting to turn a little bit more, yes. Copy this one, example 1Q. X squared minus 8x over 14 times x squared plus 8x plus 15 times 7x plus 35 over x plus 8. All right. Once again, we're going to do this one together just to get the process down. All right. So step 1 says factor completely, everything. I'm going to start with the first fraction. So before I ask Diego, tell your neighbor what to check for before we start factoring, please. What do we check for always? All right, Diego, Romo, first numerator, is it in standard form? Is there a GCF? What is it? Yes, x, and we're left with x minus 8. Let's go. All right, we have 14 on this one. How do we factor 14? Well, it's 2 times 7, okay? All right, Jose, the trinomial, is it in standard form? GCF. No. Okay, so 15 and 8. Factors of 15 that add up to 8. 3 and 5, so we got x plus 3, x plus 5 times. All right, let's go to the second fraction. Christina, standard form numerator. GCF. What is it? 7, and we're left with x plus 5. That is correct. How about the denominator? Fredo, is it in standard form? GCF? No, so we're left with x plus 8 on the denominator. We're done with step 1. Let's go to step 2. Multiply. All right? Before I call on someone, tell your neighbor what to write and in what order. What to write on the numerator and in what order. Talk about your neighbor, please. All right. Tell me what to write. Alex, go. I'm sorry? Oh, what's your neighbor say? Oh, Jaden, go. I'm sorry? All right, so once again, we rewrite the numerator completely, starting with numbers, then monomials, then binomials. So what do I write? 7 times x. 7 times x. And then my binomials are x minus 8, x plus 5. All we're doing is rewriting, guys. So with that said, tell your neighbor what to write on the denominator, please, before I call on someone. All right. Ivan, go. What do I write? Denominator. Steve, help him out. All right, so for the numerator, we wrote all of it, but in order. Numbers first, monomial second, then binomials. So for this one, we start with what? 2 times 7. And then x plus 3. And then x plus 5. And then x plus 8. Hands if you got that by yourself. Okay? All right, we're done with step 2. Tell your neighbor the giant ones, please. Giant ones. All right, Christopher, giant ones, go. X plus 5. What else? And the 7. Yes. Because there is no GCF, and the only GCF is what? I just didn't write the 1. I just put it in parentheses. All right. So what's left in the numerator? We have x times x minus 8. And the denominator we have x plus 3, x plus 8. Yes? Oh, I forgot the 2 at the denominator. Thank you. I did that on purpose to see if you were paying attention. The 2. All right. Excluded values. Before I call on someone, tell your neighbor what we're going to write in order for us to find all the excluded values. All right? Tell me what to write, please. Jessica, go. 2 equal to 0 and 7 equal to 0. Yes? X plus 5 equal to 0. Okay, so we got this one, and this one. X plus 3 equal to 0. That one. X plus 8 equal to 0, which is that one. That is correct. So, is 2 equal to 0? No. So this cancels. Is this one equal to 0? No. So, minus 5, x equals negative 5, minus 3, x equals negative 3, minus 8, x equals negative. And these are my what? Excluded values. From 1 to 5, I'll come to right over this. Yes? 5, 5, 5, 4. All right, copy this next one. You should be able to do this next one by yourself, complete. Here we go. Example 1, supercube. We got x squared minus 9 over x squared minus 5x minus 24 times x minus 8 over 2x squared minus 18x. All right, copy that and go. I'll give you some time. All right, so start with the first fraction. Numerator. We got x squared minus 9. It is in standard form. There's no GCF, but I need factors. Caleb, factors of x squared minus 9. That is correct. Hands if you got that. All right. Denominator. Is it in standard form? Yes. GCF? No. So negative 24 and negative 5. Frida, factors of negative 24. That add up to negative 5. X minus 3 and x, what? X minus 8, x plus 3. Thank you. So negative 8 and 3. Yes. Okay. Times. The second fraction. X minus 8, standard form, yes. GCF, no. So I just write it as x minus 8. And earlier, Diego asked me, Mr. Q, why did you put in parentheses? Because there's an invisible GCF of 1. Do you guys see it? Yeah? Yes? No? You don't see it because it's invisible. All right, let's go to the denominator. Standard form, yes. GCF. Fredo? 2. And what else? 2 and x. And you said x plus 9? X minus 9. X minus 9. Yeah? All right. Step 1 is done. Step 2. I need someone to give me the numerator. Let's, before I call on Valente, tell you never what to write on the numerator. Numerator. All right. What do I write on the numerator, Valente? Go. Uh-huh. Uh-huh. That is correct. Thank you. How about the denominator? Tell you never what to write on the denominator in what order, and then I'll call on Zoe to help us out. Look at the denominator in what order? Get us started, please. Zoe, what do I write? Uh-huh. 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 X minus 8. Okay. Now, guys, you do know that the binomials can go in any order, right? But we do want the monomial in the front by itself. Okay? All right. Take over the giant 1 so we can simplify this. Giant 1s. All right. Giant 1s are what? X minus 8 and x plus 3. So we're left in the numerator with x minus 3. I'll leave that in parentheses. And denominator, we got 2x and x minus 9. All right. Hands if you got all that. Yes, we got it. Okay. Exclude values. All right, what do I write? Briseida, go. 2x equals 0, which is this one, okay? X minus 9 equals 0, which is this one. X plus 3 equals 0, which is this one. X minus 8 equals 0, which is this one. Yes. So this is 0, this is 9, this is negative 3, and this is 8. All right, from 1 to 5, how comfortable are you with these? Yeah, 5, 5, 5, 5, 4, okay. One last one just to finalize this. Here we go. Copy. Actually, hold on. We're not going to have time for this one. Copy this one. Oh, my bad. Writing utensils down. Here we go. So, we're done with multiplication. Let's go to division, because I want to finalize division today. These are the steps. Don't copy them. These are for multiplication. You have them, right? This is division. Multiplication. Division. Multiplication. Division. So you're never the only thing that changes from multiplication to division. Yeah, right? Did I make it pretty obvious in red? Yes? Yeah. So with that said, copy this example down, please. Example 2. Parentheses x plus 7 squared over x squared divided by x squared plus 9x plus 14 over x squared plus x minus 2. So I'm going to do the first step in red since this is division. Everybody see the division sign right here? Yes? Okay. So it says, for division, you multiply the first fraction times the reciprocal of the second. The first fraction times the reciprocal of the second. What does that mean by the reciprocal? Yeah, you flip it, right? So we end up with x squared plus x minus 2 over x squared plus 9x plus 14. Okay? All right. And the rest is the same. Let's go with our next step, which is what? Factor completely. So this one is x plus 7 to the second power. That means we write it how many times? 2 times. X plus 7, x plus 7. Over, and the x squared is what? X times x. Times. Look at the numerator for this one. Standard form, yes. GCF, no. So, negative 2 and 1. Factors of negative 2 that add up to 1, Frida? Times negative 1. So my factors are x plus 2, x minus 1. Denominator, standard form, yes. GCF, no. So therefore, factors of 14 that add up to 9. Diego, Rosa. 7 and 2. So my factors are x plus 7, x plus 2. So we're done with step 2. Let's go to step 3, which is multiply numerators times numerators, denominators times denominators. Tell me what to write for the numerator. Lorena, go. X plus 7, x plus 7, x plus 2, x minus 1. And the denominator, since we're going on, x, x plus 7, x plus 2. All right, tell your neighbor the giant ones, please, so we can simplify this. Step 3 is done. We need giant ones. Yeah? Anaya, giant ones? Uh-huh. And x plus 2, so we're left with x plus 7 times x minus 1 over, what's on the denominator? X squared. Woo-wee! All right. Excluded values. Before I call on someone, tell your neighbor what to write to find the excluded values. All right. Delilah, get us started. What do I write? X plus 7 equals 0, so she got this one. X plus 2 equals 0, which is that one. X equals 0, yes. And we don't repeat it because it's the same thing. So this one's done. So this one is X negative 7, and this is X negative 2. Before you close, hold on. I'm missing one. You're like, no. Let's see. This one is here, yes? This one is here. Hold on before you leave. However, what was the original denominator? That one, right? Which is this one, which is that one. So what am I missing? X minus 1 equals to 0, so X equals 1. All right, we'll stop right there, guys. Enjoy your home play. See you guys tomorrow. Bye.